Now let's get a little more practice with debugging. Suppose someone asks you to write a Sudoku checker. Sudoku is a common pencil and paper game, also often seen on the computer, in which you fill in grids with numbers according to certain rules. If you haven't seen Sudoku before, it doesn't matter. We're not going to do full Sudoku. We're going to do a very simple subset of it. People would normally write out these almost tic-tac-toe-like boards. We will represent that as a list of lists. So our first row is the list 1, 2, 3. Our next row is the list 4, 5, 6, and our last row is the list 7, 8, 9. And what I want to do is just check that horizontally all the numbers are different. So this is good because 1 is different from 2, which is different from 3. This is good. 4, 5, and 6 are all not equal. This is good. 7, 8, and 9 are all not equal. But this makes me super sad because I've reused 1. This is our horizontal Sudoku checker. I'm going to write one with a bug, and you're going to help me fix it. So here I've written out our horizontal Sudoku checker. But I'm going to do it probably a little differently than you might have in the past. I'm going to use a more complicated algorithm to make it a little harder to debug, to give you a feel for how this might go in the real world. I've written a helper procedure called count. Given a number and a row is just a list, it returns the number of times that number appears. Whoa, that's ambiguous. So if, for example, you're asking for 5, it occurs once in 1, 2, 3, 4, 5, but its count is now 2 in 1, 2, 3, 4, 5, 5. And I'm doing this using reduce from functional programming. I'm intentionally throwing in lambda, Python's equivalent of JavaScript's function expression. Reduce and map and list comprehension are aspects of functional programming used by companies like Google to make their search engines faster and more parallelizable. What this does is, starting with the number 0, I'm going to go over every element in the row, and I'm going to call the current element this, and I'm going to call what I have so far the accumulator. If the current element is equal to the number that I want, I'll return 1 plus the accumulator. Otherwise, I'll just return the accumulator. Let me walk you through it on checking the count of 5 in 1, 2, 3, 4, 5. The number that we want is 5. The current element starts out at 1, so I'm going to leave the accumulator alone. Next, the current element is 2. That's not 5, so I leave the current accumulator alone. Next, the current element is 3. That's still not 5, so I leave the accumulator alone. Next, the current element is 4. Still not 5. I leave the accumulator alone. Then, the current element is 5. Whoa, happy day and jubilation. I turn the accumulator into 1 plus the accumulator, so just 1. And then in this particular list, there's actually another 5 right after that. So this is 5 again, so I'll have 1 plus 1, which becomes 2. So I'm walking down this list. How many 5s have I seen? 0, 0, 0, 0, 1, 2. Great. You could have written this with a simple for loop without using reduce, but often when you have to debug a program, it's after you've been away for a while and it looks a bit unfamiliar. So I'm intentionally giving you code that's not your usual style.